In my previous video, we went through how to tabulate Routh's array. I just want to point out one little trick to maybe save you some time. When you got, two rows and the right two terms is some constant and then a zero below it, you can just pull down this constant for this term here in the next row below that. Because look at how this thing is computed. It's whatever is here, I'll call it something times this constant minus zero divided by that same something. You're just always going to get this constant. So if you see the constant over a zero, this rightmost term in the row below it is just going to be whatever this constant is. So bring down this 4, oh, you see it again, bring down that 4 again, you see it again, bring down the 4. We had another example here. Okay, here's two rows with the constant over 0, so you bring this 480 down. 480 over 0, you bring that 480 down again. I didn't have to go through computing it by going, what would I have had to do? 22 times 480 minus 0 divided by 22. I don't need to go through that. Just bring this guy down. One thing, I always had some students who had trouble knowing which transfer function to use. The problem might give you the forward path transfer function and tell you it's in a unity feedback system. Now tell me if it's stable. For stability, you need the closed loop transfer function. So the first thing we got to do here is find the closed loop transfer function. What was our little trick for doing that? If you go through the algebra for unity feedback, it's going to be the denominator plus the numerator. That easy. This denominator, that's that thing, plus this numerator. Now you just gather up like powers of s, and there's our characteristic polynomial. So now we can start setting up Routh's array. S to the 4th, and by the way, this thing only asks us is it stable or not. So we only need, if that's all it asks for, we only need to compute as far as we need to see if we ever get a negative number. As soon as we get a negative number in this first column, we know it's unstable. Well, let's see what happens. I'll just put the first 3 down anyway. So the first row will be 1, 3, 8. There we go. The second row will be 2, 8, 0. You can always put more zeros out here, but it doesn't help. You get to at least 1 0 here, done. Don't put anything more to the right. So let's see, what do we got here? 6 minus 8 divided by 2, that's a negative number already. We're done. It's unstable. Let's keep doing it. Let's say they also asked, how many poles in the right half plane? So let's see, we got 6 minus 8 minus 2 divided by 2, it's minus 1. And let's just pull it down with that trick. 8 over 0, just pull down the 8. So now we have, what do we have? Minus 8, minus 16, minus 24, divided by minus 1, which is plus 24. And just a 0. Because 0 times 0, this is a 0 here, so this is 2 zeros here, so it's just going to be a 0 there. One more, you can just pull down the 80. So one negative number, but 2 sign changes. Plus to minus, minus back to plus. 2 sign changes. 2 right half plane poles. Again, unstable. By the way, you could do this with one line in MATLAB. You might ask, then why are we doing this? Let's take this for example. It's a one-line thing. This is how roots work. It's just parentheses, brackets, and then all those coefficients, 1, 2, 3, 8, 8. And it'll give you this answer. You'll see real part that this one has two pairs of complex conjugate roots, poles. This pair, the real part is positive, so that's the ones in the right half plane. This pole, they're good. The real part's negative, so they're in the left half plane. So MATLAB did quickly what took us some time using Routh-Hurwitz. So why do it by hand? Well, your characteristic equation might have parameters in it. Let's say it's this. Now what do? I don't know if you can just put this right into MATLAB. Okay, we've got power of 3 here, so we're going to need 4 rows. 2, 1, 0. First row is going to be 1, k minus 6. That's it. Second row is going to be 5 and k. So we don't have to go too far out. This term right here will be 5 times k minus 6 minus k divided by 5. Bring the k down, and that's it. And for stability, we require everything in this column to be greater than 0. No sign changes. So certainly k's got to be greater than 0. When you do the algebra on this guy, k has to be greater than 7.5. That's the more stringent threshold between the two. So that's what's required for stability. This k must be greater than 7.5. All right, so the next little subject here is what if you get zeros in that first column? I'll save that for another video. That's the fun part.